Good day, viewers. This is Ademola Johnson, your chemistry and biology tutor. Don't forget to share this video, like it, and subscribe. And our physical lectures have started in Christ Rock Academy for post-UME students, WAEC and JAM, entrance into nursing sciences, and so on and so forth. And the lectures start by 5 and end by 7:30. We have everywhere is bright. We have solar system. Everywhere is 24 hours light in Christ Rock Academy, kilometer 8, Saple Road, Total Junction. So God will bless you and remain Ademola Johnson. So we want to look at isomerism in carbohydrates. Isomerism is the occurrence of two or more than two organic compounds with the same molecular formula but different molecular structure. Some people used to make mistake. They define isomerism as the occurrence of two or more organic compounds with the same molecular formula but different structural formula. No, that one is the definition of one of the two types of isomerism called structural isomerism. Now, there are two types. There are two types of isomerism. These are, one is structural isomerism and the other one is stereometric isomerism, or you call it stereoisomerism. So we are going to spend most of our time in stereoisomerism. We have done structural isomerism in a different video. You can look for it, please. Then let's look at structural, just because of the definition, structural isomerism. Now, this one is the occurrence of two or more than two organic compounds with the same molecular formula but different structural formula or different structural formula. Now here there are about 4 types of structural isomerism. These are, we have chain isomerism, we have position isomerism, we have functional group isomerism, then we have tautomerism, then we have mesomerism. Now, so let's take them one by one. Chain isomerism. Now, this is the occurrence of two or more than two organic compounds with the same molecular formula but different So chain isomerism is the occurrence of two or more than two organic compounds. They have the same molecular formula, but they have different number of side branch chain. So that is a chain isomerism. So let's look at examples. Examples. Now, for example, C4H10, which is N-butane. This N means normal butane has the following isomers, also called isobutane. The butane itself is 1, 2, 3, 4. Okay. This is N-butane. And the formula is C4H10. C4, 1, 2, 3, 4. H10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. C4H10. Now, we can reduce this number of carbon out to 3. 1, 2, 3. And bring the third one as a branch, the fourth one as a branch. So we have CH3 here. Now, you can see it here. This is the same thing as C4H12, H10. Let's check. 1, 2, 3, 4. H, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, but the name of this one now, this is CH3 means methyl. But if you start counting here, this 1, 2, 3, this 1, 2, 3. So the position of carbon to which this CH3 is joined to is number 2. So this is 2 methyl. Then how many number of carbon is there? 1, 2, 3. Propane. 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 Pro for 3 carbon. Ane because we have carbon to carbon single bond. This one is also known as what? Isobutane. Isobutane. Then, which other one can we have? So that is that. Now, so in this place now, we can conclude that butane has 2 isomers. C4H10 and, this one and this one. N-butane and 2-methyl propane. So, you can go on and on to check. Then let's go on to functional position isomerism. Position isomerism. This is the occurrence of 2 or more than 2 organic compounds with the same molecular formula but different position of similar functional group. Now, what am I saying here? If, for example, you have 1, 2, 3, 4, COH. If you see, remember, this is 1, 2, 3, 4. This is butanoic acid. Now, it's an isomer to 1, 2, 3. So here now, the COH was joined to carbon number 1 here, but here it's not a branch. So what you have here, and if you count, this is 1, 2. This is 2 carboxy, 1, 2, 3, propane. They have the same molecular formula, 1, 2, 3, 4, C4, H what? 1, 2, 3, 4, 5, 6, 7, 8, and O2. The same thing is here, 1, 2, 3, 4, C4, H 1, 2, 3, 4, 5, 6, 7, 8, and 2 oxygen. So they have the same functional group, but the functional group are located on different positions of carbon in the parent hydrocarbon chain. Here now this one is joined to number 1, while this one is joined to number 2. That is position isomerism. It might be OH that is similar, might be amino group, any other group. So you can find out. Then let's go on to the next one. I just have to go about this one, but that's not the real place we are going to. So let's go to functional group isomerism. Functional group isomerism. Now, this is a type of isomerism, or this is the occurrence of 2 or more than 2 organic compounds with the same molecular formula but different functional group. They have different functional group, but they have the same molecular formula. Examples, e.g., let's look at the situation between ethanol, C, this is ethanol. Then let's look at CH3, this is dimethyl ether. Dimethyl ether. So this one, the two of them are isomers. Let's look at they have the same molecular formula. C what? C2, 1, 2, 1, 2, H what? 1, 2, 3, 4, 5, 6. H is what about here? 3 plus 3, that's 6. Then 1 oxygen, which is this. The same molecular formula. But why the functional group of this one is ether, between 2 are key. Then the functional group of this one is also OH. They have different functional group. Another one that happens that concern carbohydrate. Look at glucose and fructose. Look at glucose. Glucose is 3, 4, 5, 6. CH2OH. Then we have OH, H, OH, OH. I have H, H, OH, and H. So this is C6. H12O6. So this is glucose, D-glucose. So look at CH3, CH2OH, 2, 3, 4, 5, 6. Now this is fructose, D-fructose. Now this one is also what? Let's count. 1, 2, 3, 4, 5, 6. C6, H 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then O6, 1, 2, 3, 4, 5, 6. The same thing. 1, 2, 3, 4, 5, 6. C6, H12 now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. O6, 1, 2, 3, 4, 5, 6. They have the same molecular formula, which is C6H12O6, but they have different functional group. The functional group of this one is what? Arcanone. because you have it occurs in between what two alkyl groups, while the functional group of this one is what alkana CHO group. So that is a typical example of what functional group isomerism. Okay, now let's look at another one, tautomerism. Tautomerism. Now, this is the occurrence, only two, of two organic compounds in dynamic equilibrium. With the same molecular formula but different functional group. This one has a resemblance with functional group isomerism because they have the same molecular formula but different functional group. But where the difference comes is that the two compounds that are involved are in dynamic equilibrium. Look at this, ethanol, OH, H. This compound is called ethanol. Ethene, 2 carbon. In, you have in group plus all group. Double bond group plus all group, ethanol. This one is in dynamic equilibrium with ethanol, CH3. Okay, let me do it well. Now, look at this. What do we mean by this? Is an ethanol. The two of them have the same molecular formula of what? C2, H what? 1, 2, 3, 4. 1, 2, 3, 4. H4, 1 oxygen. So, the occurrence dynamic equilibrium is that if you put this one inside top and check later, it will turn to ethanol. Ethanol will later turn to ethanol. That's how it will be. They will be forming each other. They are in dynamic equilibrium. They have the same molecular formula, which is this, but they have different functional. Why the functional group of this one is what? Alkana, CHO. This one has in group and all group. So that is that. Then lastly here we have mesomerism. This one is the occurrence of two organic compounds with the same molecular formula but different position of the same alkyl group. Different position of similar alkyl group. In ester, for example, if you have 1, 2, 3, this is ester. Then you have O, I have this. Look at this. And look at this. Here now this is an alkyl group which is methyl. This is another alkyl group which is ethyl. C2H5, 1, 2, 3, 4, 5. So the C2H5 can leave here and come here, and this methyl group can come in. So we can have 1, 2, and have this. So now the name of this one is what? That is methyl, then 1, 2, 3. Propanoate, methyl propanoate. Why this one is what? Ethyl 1, 2. then 1,2, ethanoate. So the two of them have the same molecular formula, which is C what? C3, C4, 1, 2, 3, 4. H what? H 1, 2, 3, 4, 5, 6, 7, 8. H8, O2. So H what? 1, 2, 3, 4, 5, 6, 7, 8. O what? 1, 2. That's that. So that is mesomerism. Now let's now go to stereoisomerism. Now we are going to stereoisomerism. Stereoisomerism. Now, I want you to use the opportunity to draw those things. So I will now continue. Okay, let me go now. Stereoisomerism. Now, this is the occurrence of two or more than two organic compounds with the same molecular formula. I want you to look at the difference between this definition and the previous one. The same molecular formula and the same structural formula. But different configuration or arrangements. Let me just say different spatial configuration of atoms in their molecules. Look at something. Let's compare stereoisomerism with structural isomerism. In structural isomerism, there is occurrence of two or more than two organic compounds with the same molecular formula but different structural formula. But here now, they have the same molecular formula, they still have the same structural formula. But when it now comes to arrangement, configuration means arrangement, spatial arrangement of atoms in their molecules, there is difference. Now let's look at types. Types of stereoisomerism. Stereoisomerism. Now, there are three types of stereoisomerism. These are, first one is called, we have enantiomerism, which is also known as optical isomerism. Second one is called diastereoisomerism. And the third one is called geometric isomerism. So let's take the first one, enantiomerism. Now this is the occurrence of two organic compounds with the same molecular and structural formula. They have the same molecular and the same structural formula. With the same molecular and structural formula, but different words, different different mirror images which are not superimposable on each other. What do I mean? So now, enantiomers are the isomers of enantiomerism. They are often said